In today's video, we'll be looking at pump output for desired annular velocity. So what this means is we know the annular velocity that we need to drill a particular well. We just need to calculate the pump output required for that annular velocity. So moving quickly, let's recall that for vertical wells, we know that the required annular velocity should be between 100 to 150 feet per minute. In wells between 30 degrees and 60 degrees, we need about 150 to 180 feet per minute. And in wells that are horizontal, we need 180 to 220 feet per minute of annular velocity. Say, for example, we want to evaluate 150 feet per minute, which is pretty much the high end for a vertical well. For an 8.5-inch hole, and we have 8.5-inch hole, and we have 5-inch pipes in the well. So quickly, let's go back to the equation. Recall that annular velocity is equal to 24.5 times your flow rate, but it has to be in gallons per minute, all over diameter of the hole squared minus diameter of the pipe squared. So having known that, let's make the flow rate subject of the formula here. So your annular velocity is going to be, you multiply that quickly, dh squared minus dp squared, all equal to 24.5 times your q in gpm. So divide both sides by 24.5 to make this the subject of the formula, 24.5. So your q in gpm is easily going to be your annular velocity into diameter of the hole minus diameter of the pipe squared, all over 24.5. So plug in your values. Your q in gpm is equal to, recall we said that we want our annular velocity to be 150. Diameter of the hole is 8.5 squared. Diameter of the pipe is 5-inch squared, all over 24.5. So if we do the numbers quickly, that's going to give us your q in gpm is going to give us circa 289 gallons per minute. So that's how you work the numbers. So all you need to do is you use your annular velocity equation, convert it, get your flow in GPM, plug in your numbers, and you have your flow. Thank you very much, everyone, for listening. See you in the next video. Bye for now.